complex zeros always occur in conjugate pairs. Okay. Complex zeros always occur in conjugate pairs. Always occur in conjugate pairs. Okay. For example, if 5i is a zero of a polynomial function, negative 5i is also a zero. You never have one without the other, ever. If 1 minus I is a zero, then the conjugate pair for that one is 1 plus I. Try one on your own. 2 plus 3i, what would the conjugate pair be for that? The conjugate pair would have exactly the same numbers. It's just that if this was a minus, it would change to a plus, and if this is a plus, it changes to a minus. So if we have this 0, we also have this 0. Okay. Remember how zeros are x-intercepts on your graph. Complex zeros are not x-intercepts because there's no way to graph them. So this helps you find all of the zeros that your polynomial function has, even if some of them are not crossing the x-axis. Okay, we are going to create a polynomial function with zeros 1, 1, and negative 4 plus I. And we want this to be a degree 4 polynomial function. Well, a degree 4 means that it must have 4 zeros. How many zeros do we actually have here? Well, 1, 2, 3. It's an easy fix, though, because of what we just learned about conjugate pairs. This negative 4 plus I must have an conjugate pair, which we keep the exact same numbers. Negative 4 is left to negative 4, but then instead of plus I, it'll be minus I. Negative 4 minus I. So it's always the middle sign on the I that changes when you do a conjugate. Okay, now we're going to take our zeros and turn them into factors. Turn zeros into factors. So to do that, we have 1 and 1, so that means our function is going to have a factor x minus 1 and another factor x minus 1. Now, yes, we can also create factors from our imaginary answers. So x minus negative 4 plus I means it would be x plus 4 minus I for that one, because we have to distribute the subtraction. We always do the opposite. So x minus 1, x minus 1, x plus 4 minus I, and then the last one would be x plus 4 plus I. Now, of course, if you mixed up and forgot to distribute that negative there, it wouldn't be a big deal because you have your conjugate pair. So one of them has to be positive and one of them has to be negative. But it is a big deal that this 4 needs to be a positive in both problems. So it is a big deal that this 4 needs to be positive in both problems. You could leave your answer like that, but it's kind of ugly. Usually it will say with real coefficients.
Just a real quick announcement. Any students that are going to the engineering fair this week, you need to come into the Career Center immediately to get registered. Once again, any students that have signed up in the Career Center to go to the engineering fair, would you please stop by the Career Center so we can get you registered? Thank you.
So any of you going to the engineering fair, go work on that. Okay. So this then can be FOILed out so that we don't have these imaginary numbers anymore. So we're going to FOIL this together, and we're going to FOIL that part together, and then we're going to FOIL those results together. Okay, this one's easy because it's just a perfect square trinomial. So x squared minus 2x plus 1. Really easy foiling. This one, however, gets really ugly and complicated. Let me give myself some space. So, we are going to go, let me find a marker to do this with. X times x. So that's x squared. X times 4, 4x. X times I plus xi. Then let's go with our 4 and distribute that. So plus 4x plus 16 plus 4i. Then we do our last one. Negative xi, negative 4i, and negative I squared. Okay, so then let's combine like terms in this thing. We have an x squared, we have a 4 and a 16. We have a positive xi and a negative xi that cancel out. We have a positive 4i and a negative 4i that cancel out. We have a positive 4x. But we also have a negative I squared. Remember how I squared is negative 1? So the negative I squared actually means we have a positive 1 that we include here. So this would be an x squared plus 4x plus 21. Okay. Now we have to FOIL this and this together. So that gives us x to the 4th plus 4x squared cubed, plus 21x squared minus 2x to the 3rd minus 8x squared minus 42x plus x squared plus 4x.
Would you see Randy in the Career Center, please? Joel Johnson, would you see Randy in the Career Center?
Plus 21. Then we combine like terms, and we get our final answer. F of x equals x to the 4th. And then we have a 4x squared and a negative 2x cubed, I meant. So plus 2x cubed. We have a 21x squared and another x squared here and a negative 8x squared. So 21 minus 8 is 13. Plus 1 is 14. It's really easy to make mistakes when you're combining like terms. Negative 42x squared plus 4 is a negative 38x. And then last but not least, 21. There is the polynomial function that would have those 4 zeros. 2 reals, 1 and 1, 2 imaginaries. Negative 4 plus I, negative 4 minus I. Next video will show us how to take this and find all those zeros.